In this video, we are going to prove that triangles are congruent using ASA, or angle side angle, and AAS, angle angle side. First, we're going to look at ASA, or angle side angle. So with angle side angle, you're going to have two sets of angles that are congruent, and the side needs to be in between those two angles. So, with these triangles, the first set of angles would be angle A congruent to angle D, because they both have a single arc. The side would be side AB congruent to side DE. And then the second angle would be angle B congruent to angle E. So by having an angle, a side, and an angle, we're able to say that triangle ABC is congruent to triangle DEF using angle side angle. Now we're going to look at a couple proofs where we're going to use angle side angle. So this proof says that we're given SQ bisects angle RQT, and it bisects angle RST. And then we're trying to prove that triangle QRS is congruent to triangle QTS. So, the first statement they gave us was that SQ bisects angle RQT and angle RST. That's given. And then I'm going to put that into our picture. So SQ is bisecting each of these angles, which means that this angle and that angle will be congruent to each other. And then over here, those are congruent to each other, which is what lines 2 and 3 are saying. So angle RQS is congruent to angle TQS. We know that because the definition of bisect. And then the same thing's happening with line 3. Angle RSQ congruent to angle TSQ, once again, definition of bisect. And now line 4 says QS is congruent to QS. So side QS congruent to itself. We call that the reflexive property. Hopefully we remember that. And then the last line, triangle QRS is congruent to triangle QTS. If it's easier to look at these triangles outside of the picture, where they're not touching each other, you can pull them apart. And you can see we have an angle, a side, and an angle. Angle, side in the middle, angle. So we have, they're congruent by A, S, A. Now we're going to look at proof 3. So we're going to skip over 2. This says it's given that angle BAC is congruent to angle DEC, and C is the midpoint of line AE. So this one, we need to write the statements and the reasons. So I'm going to start with angle BAC congruent to angle DEC, because that was given. I'm going to put that in the picture. So angle BAC would be here, and angle DEC up here. And then the other part of the given, C is the midpoint of AE. Also given. And then I'm going to put that in the picture too. So C is the midpoint of AE, which means that each half is the same. So tick mark here, tick mark here. So now I need to put that into my proof. I need to put that AC is congruent to EC. And the reason I know that is definition of midpoint. So that gives us a side. And then we have an angle given to us up here. So we need one more angle to be able to use angle side angle. What I see in the picture is vertical angles. So I'm going to say that angle BCA is congruent to angle DCE because they're vertical angles. And that gives me another angle. So we can see in the picture we have an angle, a side, and an angle. Angle, side, angle. So I can end my proof with what they want me to say. Triangle A, B, C congruent to triangle EDC by angle, side, angle. Now we're going to look at the other version, AAS, or angle, angle, side. So the biggest difference between angle, side, angle versus angle, angle, side is that the side is in the middle of the two angles here, and with angle, angle, side, the side is not in the middle. So that's our biggest difference here. So with angle, angle, side, you're going to want two sets of angles and then a side that is not in between those two angles. So in this picture, we have angle A is congruent to angle D. We have angle B congruent to angle E. And then we have side BC congruent to side EF. That gives us an angle, and a side, or AAS. Once again, that side right here is not in the middle of those angles. If it was in the middle, it would be here, but it's not. It's not in the middle. And that's the most important part. This is definitely the type that most students would get mixed up are these two different versions. So once I have that, I can say that triangle ABC is congruent to triangle DEF. Now we're going to look at a couple proof examples with AAS. So once again, we need to write the statements and the reasons. We don't have the statements given to us. We're told that YZ bisects angle WYX, and that angle WYZ is congruent to angle WXZ. So I'm going to start by putting my givens in the proof. YZ bisects angle WYX, and then angle WYZ is congruent to angle YXZ. These are both given. So now I want to put those in my picture. So WZ bisects angle WYX. So that means this angle up here is getting split in half. So those two sides are congruent. And then angle YWZ is congruent to angle YXZ. So we have another set here and here. So at this point we have two angles. So this gave us an angle. And then this is going to give us an angle, but we need to write that statement that the angle is congruent. And the two angles that are congruent are angle WYZ congruent to angle XYZ. And that's the definition of bisect. So now we have another angle. Now we just need a side. The side that I see is the side that they share. So what I would say is YZ is congruent to YZ. And that is reflexive. So if it helps you to draw the triangle so they're not sharing the side, you can do that. We have this angle and this angle up here, and then the side. So I see angle, angle, side, angle, angle, side. So I can now end the proof and say that triangle WYZ is congruent to triangle XYZ by angle, angle, side. And then we're going to look at one more proof with AAS. So we're told that angle ABC is congruent to angle CED. AB is parallel to CE, and that C is the midpoint of AD. So I'm going to put my givens in. Angle ABC congruent to angle CED. AB is parallel to CE, and C is a midpoint of AD. And then I'm going to put all that into my picture. So angle ABC is congruent to angle CED. It'll give me those two angles, so that's going to give me an angle. And then we're told that AB is parallel to CE, so that's not necessarily giving me anything, but I will put some arrows on the lines to show that they're parallel in case we forget. And then C is the midpoint of AD. So C will be in the middle, which means that this is congruent to that. Whoops, let me rotate that back for you. So we have two sides that are congruent down here. And all three of those are all given, so I can put that as the reason. Given, given, and given. Now I need to have a couple more statements to get to angle, angle, side. So we were able to say that those two sides of the midpoint were congruent, but I don't have that statement written in my proof. So I need to say that AC is congruent to DC by definition of midpoint. So now that's going to give us a side. Now I need to check and see if I can get another angle to be able to use angle, angle, side. So if you think back to having those parallel lines, I'll be able to mark off angle A congruent to angle ECD. If you look at it outside of the picture, those angles are corresponding from the parallel lines, and corresponding angles are congruent. So I'm going to say that angle A is congruent to angle ECD because of corresponding angles. And that gives me an angle. But you just want to make sure that you're checking the order in your picture. If you look at the two triangles, if you draw them outside of the picture so they're not touching each other, got angle up here, angle down here, and then this side and this side. So we have angle, angle, side, angle, angle, side. The side is not in the middle, so we're using AAS to show that triangle ABC is congruent to triangle CED. Now you can try examples 2, 6, and 7 yourselves.